Hello, everybody. My name is Misha Teplitskiy. I'm an assistant professor at the University of Michigan School of Information. And I'm excited to share with you guys some work James Evans at the University of Chicago and myself have been working on for quite a while. This project is about the credibility of social science empirical literatures. And in particular, in this case, we're going to be focusing on sociological literatures that are kind of survey-based and will focus on the studies that use the general social survey. The question we try to address with this work is, or the problem we try to address is how to measure the credibility of empirical literatures, because currently it's really, really hard. And when thinking about how one might do this, we can kind of consider three aspects of credibility. How much should we trust published findings? Those three aspects are reproducibility, and this is whether you get the same results when you apply the same methods to the original data. You would hope that, yeah, if you kind of repeat everything, you should get the same results. Replicability and definitions kind of vary here, but we'll take it to mean whether you get the same results when you apply the same methods to different data. So maybe you have another sample of subjects that you use. Again, you kind of, if the samples are pretty similar, you hope you would get similar results. And lastly, robustness is a kind of even more vague kind of term, but we here take it to mean whether you get same results when you apply similar but not quite identical methods to the same data. So for example, maybe you should tweak a variable and an analysis that you do. All of these things can be affected by a variety of factors. In particular, they're kind of widespread concerns that there's a lot of p-hacking or selective reporting going on, meaning that researchers and authors of papers don't show you kind of everything they've tried in their analysis, but only select the things that gave them the right statistical results, the right p-values, and only report those. Additionally, something that's even harder to get at is social change. So something that was true at one time may, due to social change, turn out to be not true 5 or 10 years later. So that can, social change can also affect replicability. And so how can we do this at present, measure these kind of aspects of literatures? So it's really hard and generally involves a lot of kind of careful effort. People, different labs might redo a study using different samples. And this, of course, is kind of hard to do at scale, especially for replicability, because kind of you need new data, right? New data is generally expensive. So there are kind of persistent questions of how can we make this easier, scale it up? How can we automate this? This is an active area of research. So people are proceeding at sort of different directions. So what we do with this work is we propose an idea that we haven't seen in this literature yet. So we hope it's useful. And the idea is to use surveys, especially those that are public and recurring. And the big kind of benefit with focusing on that is the survey is recurring, and especially if it's asking the exact same questions, maybe to different kinds of, to different sort of samples of subjects, respondents, you kind of get basically the exact same sort of type of data, but now in a different sample of people, right? And that's sort of ideal, because now you can see if the original findings that people found with one sample also are found in the new sample. Also, if the data is public and the analysis is public, let's say reported in a paper, then we can also try to tweak that analysis, and we have the data, so we can see if we get the similar sort of results that the paper finds, right? So that's the big takeaway from this project is this idea, using surveys to kind of automate analysis of replicability and robustness. So here's how we do this. Let's see if this works. Okay, so we focus on the general social survey. In principle, we could have used others. You know, the census could be a source. But the general social survey is particularly attractive for a few different reasons. So it's a survey that has been running consistently since 1972. It's fielded by the National Opinion Research Center, NORC, of the University of Chicago. You often see findings, you know, in newspapers, sort of all over the media. For example, this figure on the right. Anything about attitudes, and especially over time, often comes from, in the States, often comes from the general social survey. So it's a representative sample of Americans. It's on the order of, I think, 3,000 to 5,000 respondents a year. And over time, there's been more than 20,000 publications. At this point, probably a lot more than that. That have used this work. So it's very commonly sort of used over the social sciences and media. And again, our idea is that every time a new wave comes out of the survey, it gives you an opportunity to test the credibility of the previously published work. Another very useful feature of the general social survey is that, at least for a while, the staff that fielded the survey curated a bibliography of the papers that used it. So we go to this bibliography. In it has the paper, the data, the years of the survey that it used, the variables that it used. We supplement that with some manual coding, labeling from RAs. So the RAs also went and looked at these papers and labeled them for kind of the type of analysis they did. Was it a kind of linear regression model? Was it a nonlinear regression model, or maybe something else altogether? And they also identified, like, what's the dependent variable, what's the independent variable, and among the independent variables, what's really central to the analysis and what's kind of supplementary, like a control variable. So the RAs were able to do this for about 1,000 papers on this bibliography. And that forms our kind of data set. This is the literature that we're going to try to assess the credibility of. Okay, moving on. The closer look at the methods. So we'll look at both replicability and robustness. So again, replicability is whether you get same results applying the same method to similar but not identical data. And so in general, we'll focus on papers that have used linear regressions. That seems to be a pretty good kind of, we can't do this sort of precisely because papers often use more than one method you know, at a time. But generally, at least in this literature, that seems to be kind of the most common analysis method. And we will run these regressions for kind of the original data that the paper used. And more narrowly, we use the last wave of the original data that the paper used, because often people would pool several waves together. We kind of focus only on the last one. And then we'll compare what the results look like on that last wave of the data that was available to those researchers versus data that came out after the paper, right? That researchers didn't have access to at the time. And so if we estimate things on the data that the paper actually used and the very next wave of the data, you know, that's probably our best case of best sort of test of replicability, because the time in between is on the order of 1 or 2 or 3 years. So not a lot of time has passed. Social change should be pretty minimal. And so we basically just get another sample of subjects and see if the findings hold up. Additionally, and this is a very cool kind of feature of this approach, is that we can compare the results on the last wave of the original data versus waves that came much, much, much later, let's say 10, 20 years later, right? This is a benefit of using such a long running survey, then we can see the results showed up 20, 30 years later, right? So that's one aspect of the project. The other is robustness. So do we get the same results when we tweak the actual analysis method? So again, we kind of focus on papers that have used linear regression. And what we do is we change one variable, quote unquote, slightly. So what we do is the General Social Survey has all the variables divided into kind of like a tree where they're semantically related. You know, some are attitudes about abortion, and maybe there's different set of questions for that. Some are measurements of people's educational attainments, different questions on that. So we look within variables that are in the same part of the tree, I guess in the most bottom sort of branch. We know that these are semantically related because that's how they're organized by the survey creators. And we look for ones that are really highly correlated, so 0.7 plus. And so we then now have these pairs of variables that we believe measure kind of a similar concept. They're highly correlated, but they're not the same variable, right? And so the question is, when we switch out one of these variables for another and estimate the same model that the paper used on the same data that the paper used, are we going to get the same results? And if the findings are really robust, we imagine that this change shouldn't have much of a difference. If they're not robust, then the findings may used to be significant because maybe the research even chose the variable to report, the one that gave the most significant results. But now that we were able to change it, maybe we see that those results are no longer significant, right? So that would be kind of the case of p-hacking. So this table here on the right shows the most common substitutions that we did or that we ended up with. You see that the most common is substituting the education variable for the degree variable. So education is number of years. Sorry, and the degree is numerical coding of basically what degree you have, high school, you know, or non-high school, high school, and so on. And so, you know, intuitively, these are both measuring educational attainment. Maybe there's cases where one is very different, like theoretically only one makes sense. But broadly, we imagine that measuring education either of these two ways should probably give the same results in the majority of cases if the findings are indeed robust. And here are the results. So first on the robustness and this kind of variable substitution that I just described. So here on the left, we have a panel that shows on the x-axis how much change there was in this outcome. And you see 6 different rows. And each row is a different measure of how well the results match. So the first 2 rows are model fit, measured as R squared, and adjusted R squared. What we see is generally after the substitution, the model fits less well, right? So substituting in the cognate variable, for example, degree, decreases how well the model fits, which is kind of you know, somewhat concerning, although the effect is not huge by any means. The second set of 2 rows looks at the variables that the RAs identified as being central to the analysis. And we see that the biggest change here is that the number of statistically significant coefficients decreases by quite a bit, by almost 30%. On the other hand, the effect size, the size of the absolute value of those coefficients that are standardized goes up a little bit. And lastly, bottom 2 rows show that the size, the absolute value of these coefficients for the significant coefficients, now the middle 2 rows looked at variables identified as central, and then the bottom 2 rows looked at all the variables and show that the number of statistically significant effects went up a little bit, and the effect size went down a little bit. But the main kind of story looking at this graph is that the number of statistically significant central variables drops, right? And it is the central variables that we're substituting. We're not playing around with the controls. So this could be taken as some, as evidence of p-hacking, that we changed one variable to something similar, and yet suddenly things became quite a bit less significant. Now on the right panel, and I'll try to move that away, we kind of zero in on this number of statistically significant coefficients, and we see that the original models had quite a bit more things at 1.0, meaning all of those central variables were statistically significant. After we do that change, that's no longer the case. So moving to our second set of findings, this is now kind of concerning replicability. Previous was robustness, this is replicability. We kind of do a similar sort of look at 6 different outcomes: model fit, proportion of variables that are statistically significant in their size. And we see that when we estimate the models specified as they are in the paper, run them on the original data, the last wave of the original data, and then the very next wave of the data that was available, we see that the model fits less well. R squared decreases by about 7%. Coefficients get less statistically significant and smaller. Right, so in general, we see that when we substitute in a similar sample of people, the results don't hold up quite as much as they did in the original data. And lastly, and this is probably the part of this project I find most cool, is we can, instead of substituting the last, sort of the very next wave of the survey that was available, we can do, that wave, the next one, the one after that, and so on for as much data as much time as has elapsed since. And that's what we show here on the x-axis. We see for each of these kind of 6 subplots, we see years after publication. And generally, we take the difference between the models as estimated on the new data minus models estimated in the original. And what we see is that in general, this quantity for model fit, top row, central variables, middle row, and null variables, bottom row, gets worse and worse over time. Not quite linearly, kind of plateaus out, you might say. And at each of these data points, the composition of the papers is changing too, which is important to keep in mind, right? Only some papers had 35 years of survey data that has accrued, right? Those are much older papers than those that are towards the earlier part of the curve, of the line. But generally, we see that things get kind of fit less and less well over time. And in fact, the size of these changes kind of overtakes what we see on the panel on the left, which is sort of kind of the most proper test of replicability. And I'll interpret this on this last slide, which is the conclusions. So our main kind of contribution is to propose a kind of proof of concept or provide a proof of concept. And the concept is that surveys provide a very useful way to measure replicability or credibility overall of literatures at scale. Now, of course, that doesn't apply to all scientific or social scientific literatures. I guess most of them probably don't use survey data, but those that do, and that's public and recurring, that seems to be a very fertile ground for doing analyses like ours. So as far as robustness, we see that when we substituted in a different variable that was cognate, the models fit less well, but not by a humongous amount, like things didn't completely fall apart. it's not like we went from everything was statistically significant to nothing. So there's, you know, we can take this as kind of moderate evidence for p-hacking, or evidence for moderate p-hacking, you might say. Replicability is when we change the data that we estimated the models on. We see that when we do it kind of the original data versus the very next sample, model fit got worse. But when we use not only next sample, but sample after that, and so on, model fit kept getting worse. And so our conclusion then is that social change, which you expect, you know, in the course of 20 years, 30 years, is actually the thing that's kind of decreasing the credibility, or in this case, the replicability of the literature overall, probably more than p-hacking and so on. Right, and this is kind of a point that I think is worth highlighting, and it's really hard to get at empirically. We kind of like suspect that when we read things from 30 years ago, they're probably not as relevant to us as the stuff from 2 years ago. But it's been, you know, how do you show that empirically? Well, here's our kind of actual attempt to quantify that. And to put this in context, overall, I mean, I think the kind of decreases in replicability we're seeing here are kind of less severe than reported in other kinds of studies and literatures, right? So we, I think, you know, have very careful kind of direct replications of existing experiments, and those kinds of meta-analyses and many labs studies show that a very large fraction of things don't replicate, maybe on the order of 50%, if not more. We don't quite see that level of problems in this literature. And a very interesting question is to ask why. Maybe our methods are bad. Okay, that could of course happen. However, there are some crucial differences that might also be important. So first, the data and the kind of the papers we look at tend to use, you know, or they use the general social survey, which tends to be a relatively large data set compared to kind of small scale experiments that some of these other literatures use, right? So we were talking like thousands of subjects for the general social survey. Other experiments, you might be talking dozens. So that could be a big reason things appear to be more robust and replicable here. The data that we focus on is public, right? So that maybe also prevents people from kind of selectively reporting as much as they would have, since their reviewers, editors, et cetera, might kind of know what's not being reported. And lastly, we're focusing on papers here that have been curated by NORC staff, the people that run the GSS. And they kind of were curating this literature until sort of the resources, until it got kind of too expensive. And so the literature we focus on here is on the older side. So it's 80s, 90s, early 2000s, right? And maybe the problems were less severe at that time, perhaps, right? So these are all important questions for future work. But we hope that in general, the method is as interesting and intriguing to you guys as it was to us to experiment with. And thanks for your attention.